proof asks me to show that I have perpendicular lines. You can see CF appears to be perpendicular to AE. The question is, do I have enough information really to show that, which is what we'll be trying to do here. I'm told that angle 1 is congruent to angle 4. And I'm also told that BFD is bisected. So I know that that angle there is congruent to that angle there. I'm going to go ahead and add in that angle 2 is congruent to angle 3. And that is if an angle is bisected, then it is divided into congruent angles. Pretty straightforward there. You'll notice now, this kind of looks like it's going to be an equidistance theorem problem, but to show that I have perpendicular lines using the equidistance theorem, I need 2 points equidistant from the endpoints of the segment. I'm not told that F is a midpoint. I'm not told that C is equidistant from the endpoints of AE in any way. So always a good thing to look for, but not going to take me anywhere in this example. However, I do notice that these angles on both sides are marked the same way. I can show that angle AFC is congruent to angle EFC. And notice that's just because I have equal angles and I add equal angles. That's the addition property. And again, I do have to have shown all of those angles congruent first to be allowed to use the addition property, but I already had that information in this case. And then I noticed something. If I showed this angle congruent to that angle, I now have two angles that are congruent. If I can show they're also supplementary, I know they'll both be right angles, which means the lines forming them are going to be parallel. So I'm going to say that angle AFE is a straight angle, okay, and that is assumed from the diagram. Make sure you put that step in there, that you have a straight angle. And so what I'm going to be able to say at this point is angle AFC is supplementary to angle EFC. So we have AFC here, EFC there. They're supplementary. If angles have a sum of a straight angle, then they are supplementary. And now I've shown that the two angles are supplementary and they're congruent, which means that angle AFC and angle EFC are right angles. Why are they right angles? Because they're congruent and supplementary. So if angles are congruent and supplementary, then they are right angles. And the final step here, I've shown that I have right angles. Now I just need to show that the lines that form them are perpendicular. So I'm going to say that CF is perpendicular to AE, and the reason being, see there, if lines intersect at a right angle, then they are perpendicular. And that's all I need to do to finish out my proof.